Hello everyone. So we are continuing with our design pattern series and today we'll cover composite design pattern. So let's get started. So again in this video we'll start with what is composite design pattern, why we use it, how to achieve it, then code implementation in C++ and finally benefits and disadvantages. So what is composite design pattern? So first of all, it's a structural design pattern and it allows you to compose objects into tree structures where the objects are typically of two types: individual objects, we can also call it them as leaf objects if we are talking like in a tree terminology, and composite objects which contains individual and composite objects. So it is like a recursive tree structure where you can assume you have a root node. In the root node you can have a leaf, or you can have again a subtree, and so on. So now we will see which type of systems can fit into this hierarchy and where composite design pattern can help us. So then why use composite design pattern? So consider an example, consider a graphic design app. So if you notice, graphic design app has many different types of shapes like circle, rectangle, triangle and other type of shapes. Now you can also have a complex shapes in the app, right? For example, in here we have taken the smiley face. Now you can see smiley face contains the individual shapes also. For example, it is a circle which contains two more circles. We can consider this as a small rectangle. Maybe this is a semicircle, right? Maybe we can have another smiley face inside this smiley face, or maybe another some complex structure, right? Anything could be here. So this smiley object or smiley shape is a complex object which in turn contains individual as well as other complex objects as well. So for these type of systems, for these type of designs, composite pattern can help us. How? Okay, consider an example where you have to display this smiley face. So now do you want to display all of these individual objects separately, or you want to just display the smiley object and it in turns displays these individual objects? So this is where composite pattern help us. It allows printing the entire face, which in this case is a complex object, without worrying about its components. Other examples of this kind of system could be a file system. File system also has a clear hierarchy. You might have a root directory. Inside that you have a bunch of files. Then you have a maybe user directory. Again, inside that you can have a bunch of files. Again, some other directory and so on. So it's directory inside a directory, or a directory can contain individual files as well. Now let's see how composite design pattern achieve it. So it's a very simple design pattern. It just enables this using a interface. So you can create a component interface, and whatever functionality you want each object to possess, for example our individual object and our complex object, you can have those functionality in the interface. For example, if let's say we are talking about a file system example and we want to display the entire hierarchy if you give any directory as an input. So the function is display. Now the individual file object will also implement this display, and the directory, which in this case is a complex object because it contains components inside it. So its children are component. These component could be either file or directory itself, and then it also implements this display function. So that's it. Now let's see this code in C++. So now let's go to the file system. Now we created this interface, file system component. It has a display function which needs to be implemented by all of its classes which implements it. So in this case we have created a file class which implements the display function. It only has a one variable which is name, because we are going to print the names of all the files. Then we also have a directory class which also implements this component, and it has a name and it has a children. It can have bunch of components as its children, though those could be file or directory, and it also implements this display function, or in this case override in C++. So if we look at it, the display function of file looks like it just prints the file name, while the display function of the directory is what? It first prints the directory name and then it iterates over all the children and call their display function. So it doesn't care about what are its child. They could be leaf objects like file, or they could be individual directory, which in turn will call the display function. So it is like a recursive display call happening, but the directory doesn't have to worry about this. Now if we look all of this together, let's say we have this client where we create one root directory. Inside that root directory, you can see we are adding one file. We name it root level file just to be more explicit. Then we create one home directory, and in the home directory we add one more file, which is home level file. And then we have a user directory which contains bunch of user level files. Then in the end we add home directory in the root, and then we add user directory in the home. So this is how the hierarchy looks like. So we have a root on top, then we have a root level file. Inside root we have a home directory. Inside that home directory we have a home level file, and we have a user directory, and inside user directory we have a bunch of files. So now if we look at this and run our code, so this is what it prints. It prints first root directory, all the files in the root directory, then it prints the home directory, all the files inside home directory, and then it prints user directory and all the files in the user directory. So I hope this makes sense, and this explains. Now this was very easily done using the composite design pattern. If you have to do it manually, then the root directory has to iterate over all of its components or all of its children and call their display function. And if the child is also a complex object, it has to manually go inside it and print the display again. But due to this interface availability, directory doesn't have to care about how its children will be displayed. It is recursively handled. So that's it with the code. Let's come back finally to the benefits. We can all see we can easily work with complex tree-like structures more conveniently using this design pattern. And you can also introduce more elements in the app without breaking the existing code. Let's say if you want to add one more type of object, you can implement that interface, create a class for that, and add maybe children or whatever you want to do. So basically it also follows very common open close principle. So it is open for extension but close for modification. And client treats both simple and complex objects uniformly. Client doesn't need to know that whether they are dealing with simple or complex object, because they just have to call the display function, which is a common functionality by both type of objects. Now disadvantages, again, one disadvantage could be, now the assumption we are making with this pattern is that client doesn't want to differentiate between different type of object. But let's say if the objects are very different from each other, they have a very little common functionality, so the interface you will have to create will be very generic. And in that case, the client will not be able to call the specific functions of each object through that interface. So this pattern typically works when you have a closely related objects, or your objects are coupled together, coupled with each other tightly. Then another disadvantage could be the debugging tree structure can be complex. Because of the recursion happening, you have to debug at what point, if there is any error, at what point that error has occurred. But despite all of this, this pattern is very useful and also very simple to use by using a interface. So that's it with composite design pattern. I hope you understood now. And if you like this video, please hit the like button. And if you have any doubt in this pattern, or if you think I missed something, please let me know in the comments below. So that's it with this video. Thank you everyone, and I'll see you in the next video. And meanwhile, you can watch my other design pattern videos. Bye everyone.